Thank you for joining this lesson. We're going to look at area approximation using the trapezium rule and also the mid-ordinate rule. Find the area enclosed by the curve y equals to x squared minus 2x plus 5 with the x-axis between x equals to 2 and x equals to 5 by using part A, the trapezium rule, using 6 trapezia for 4 marks, then part B by the mid-ordinate rule using 3 mid-ordinates. So what I'm going to do first is to get the heights of the trapezia. Remember, we need to first of all get a table of values of x and y such that the values of y are going to give us the heights of the specific trapezium. So each trapezium will have a height which is equal to the value of y, because y is plotted in the vertical axis. So the values of y will represent the heights of each trapezia. Now, something else we should know is that we are given between 2 and 5, whereby the range of units is 3, but we need 6 trapezia, which means instead of using intervals of a complete unit, then we need to use half. So we use half intervals for us to get half units for us to get 6 trapezia for this curve. So what you're going to have is the first value as 2, then the next one should be 2.5, so that we go to 3.0, 3.5, then 4.0, 4.5, then 5.0. Now in this case you realize that we're going to get 1, 2, 3, 4, 5, 6, 7 intervals. But now because this is the first boundary, then we're going to have 6 trapezia, because from the first value of y to the next is when we get the first trapezia. So we're going to have 1, 2, 3, 4, 5, and 6 trapezia. So let me now get the specific values. When we substitute the x values, we're going to have the first one as 2 squared, then minus 2 into 2 plus 5. This is giving me 5. The next, I'm going to substitute 2.5 squared, then I subtract 2 into 2.5 plus 5, and this gives me 6.25. 6.25. Then I should continue. The next one will give us 8. The other one 10.25. The next one 13. The next one 16.25. Then the last one is going to be a height of 20. So now to use the trapezia rule, area under a curve is going to be given by half multiplied by h into y naught plus yn, then we add 2 multiplied by y1 plus y2, then we continue adding the values of y until we add y just before the nth. Then we lock the brackets. So I'm going to have half multiplied by height, or h is the intervals from one trapezia to the next, and the intervals we are using are for 0.5. Then in this other side now, y naught is going to be the first height which is 5. Then we had yn, which is the last, that is 20. Then we add 2 multiplied by all the other values of y in between the first and the last, whereby we will start with 6.25 plus 8 plus 10.25 plus 13 plus 16.25. So now this is going to be 0.25 into, this is 25. Then we add 107.5 units. Then now when we add and multiply by 2, we're going to get 33.125. 33.125. So this is going to be the area using the trapezium rule, square units. Now part B, the mid-ordinate rule. So for us to use the mid-ordinate rule with 3 mid-ordinates, now we need the mid of the heights, and we need 3 of them. So for us to use 3 mid-ordinates, we need to get back to the table, and we see now, if we consider from 2 to 3 as the first rectangle, so we're going to have from 2 to 3, then from 3 to 4, and from 4 to 5. Then now we get the values at the mid. The values at the mid, whereby the mid of 2 and 3 is 2.5, and the y at that point is going to be 6.25. So the first mid is going to be this one. The second is going to be at 3.5, and the last one is going to be at 4.5. So when using mid-ordinate rule, depending on the mid-ordinates we are using, that is how we identify the heights at the mid. Therefore, we have a height, another height, then one height at the mid. We also have a height of 13, and another one at the mid. Then the last one with 13, 20, and 16.25 at the mid. Therefore, now we will say area using the mid-ordinate rule is usually given by height multiplied by the summation of the initial value of the mid-ordinate plus the next ordinate plus the third, and the additions continue until we add the last one. Therefore, what I'm going to have for the mid-ordinate rule is a height. Now, between the ordinates, we have an interval of 1 unit, because from 2.5 to 3.5, I got exactly 1 unit. From 3.5 to 4.5, I got exactly 1 unit. Therefore, h in this case represents the intervals between the ordinates. Then the first ordinate, according to the table above, 6.25. Then we add the next one, 10.25. Then we add 16.25. Remember, finally, we're going to multiply by 1. This is going to give us 32.75 square units. So that is the area using the mid-ordinate rule. Finally, we are told to find the percentage error using the mid-ordinate as compared to the trapezium rule. So using the mid-ordinate as compared to the trapezium rule, we're going to consider trapezium rule as the point of reference to compare how accurate the mid-ordinate rule is. Therefore, I'll use the area using the trapezoidal rule, which is going to be 33.125. Then I subtract 32.75. And because we are getting the percentage error, remember this difference will give us the error. When we divide with the value being treated as the point of reference now, 33.125, to make it a percentage error, I'll have now to multiply by 100. So when you work out this computation, we're going to get exactly 1.132 percentage. So that is the percentage error in the calculation of the area using the mid-ordinate rule as compared to the trapezoidal rule. Thank you for following. Subscribe and share.